Well, welcome to today's webinar, everyone. We'll go ahead and get started. We have a lot to cover and not a whole lot of time. We calendar these off about an hour long just to block out the time, but we know everyone's busy, and so we try to get the information delivered in as quick a subset of that as possible. So we'll get going, and we have a a massive throng of people, very high interest in this particular webinar. So let's get going. So Octopus Deploy is probably the first and most mature product for automated deployments, making it easy to orchestrate releases and deploy .NET applications to any data center in Azure and any cloud. And whether you're a current user of Octopus Deploy or other tools, there's always a mix of them. And working on your DevOps automation, you do need a streamlined DevOps architecture for promotion across both pre-production and your production environments. You also need to limit who can deploy to production, ensure that releases have been tested first, and don't allow broken release candidates to get into production. And so, a lot of teams are asking common questions about how to structure their deployable application components and how all these fit together. And also, as technology is moving forward, we want to integrate new things like .NET 7 and Azure Container Apps and other technology into the deployment environment. And we're going to marry all of that today. And so let's get into that. Now, a little bit about ClearMeasure. We're a US-based software architecture company that's empowering software delivery. We're enabling in-house .NET development teams to be self-sufficient, able to move fast, deliver consistent quality, and ultimately to run your software systems with confidence. And we're both a provider of fractional software architects, but also serving the leaders of the teams in-house. And so we want to help you get more done with what you have in-house. And whatever that looks like, from advice to jump starting. So that's what we do. We focus on the Microsoft platform, that entire ecosystem. And so if you're a Microsoft shop and you're looking to jumpstart or get over a hump, give us a call. We'd love to help. I do want to offer my latest book free, a free digital copy if you'd like. You can just send me an email. Johnny will be helping me out in the chat as well. But .NET DevOps for Azure has been out for a couple of years now. There's new tech, but this focuses on the architecture and the philosophy and the way of thinking about empowering your team to have a good environment for that. So that's an offer, just if you want to have that. Also, a few other resources. I'm the host of the Azure DevOps podcast. And so if you like listening to podcasts, you can find it in any of the podcast directories. If you search for Azure or DevOps, it's typically in the top 5. And then also there is a new video show that I started called Programming with Palermo. And we're up to episode 20 or 21 at the moment. So it's fairly new, almost half a year since we've been doing it, but it's fun and it adds the video element to it. Also, you might want to look back in the webinar archives. I really enjoyed doing a joint webinar with the founder and CEO of Octopus Deploy, Paul Stovall, where we focused on Octopus Deploy in a database setting and how to properly think about managing relational databases when you're working on your DevOps environment and Octopus Deploy. And so we shortened that link. You can find it at bit.ly/Octopus Database. And so you might be interested in that if you were not a live attendee of that webinar. So that was fun. Okay, so our agenda for today, lots to cover, but this is not a pitch for any particular technology. We're going to talk about a lot, but it's not a pitch. I'm not going to try to sell you on you should be using this or that. That's not the goal of this. And we're going to be working at the architecture level here to discuss how these different things fit together. .NET 7, Azure Container Apps, Octopus Deploy. We'll also be using Azure Pipelines. We're using Visual Studio 2022. So lots of different things. We're going to look at how they work, what our options are, and with the .NET Conf announcements just a couple weeks ago, I would expect the .NET.exe tooling to be improving over the next year. They're making containers easier to work with. And Microsoft, their philosophy, they realize that for containers to really go mainstream, they need to take the requirement away of having Docker installed on the local workstation and Docker desktop and all that. And so if you're thinking about Microsoft's target of enabling more scenarios to use simple computers instead of full-blown workstations, maybe in the education space, then they have to simplify the tooling because of the dependencies that it currently has. So that's going to keep moving. That's going to keep moving fast. But what we're going to do is we're going to introduce these new technologies. We're going to review some of the existing ones. And in the category of existing ones is Azure Pipelines and Octopus Deploy. We're going to implement our DevOps environment and show how that is stitched together with the existing and the new technology. And then we're going to finish. We're going to highlight some of the gotchas or some of the things that are a little bit different when you're pulling in this new tech, when maybe you've used Azure Pipelines and Octopus Deploy. Now, for those who have really gone deep in Octopus Deploy and maybe Azure Pipelines and even marrying them together, we're not going to go deep into the details of how to use Octopus. And so if you've never used it before, just know I'm not going to do that. And for those who are expert level already at Octopus, I'm going to breeze through some of these things because I really want to highlight .NET and Azure Container Apps and kind of how it fits in. So I am going to gloss over some of those things. This is not a Octopus tutorial webinar. We've done plenty of Octopus content in the past. So just to kind of set the stage and what to expect. And by the way, if anyone has a deeper question, that's what we're here for. So whatever you need afterwards, just follow up and we'll get you on down the road. Okay, so .NET 7, what is it? By the way, if you have not watched the videos from the .NET Conf 2022, it's on YouTube, it's on Twitch, even linked to on learn.microsoft.com. Just go and watch them, or watch them at double speed. But anyway, what is it? It's another short-term release, going to be supported for 18 months. It is a drop-in seamless upgrade from .NET 6. So if you have code that's .NET 6, it is super quick, like less than 20 minutes to upgrade from .NET 6 to .NET 7. And some of the key features, actually the biggest key feature in .NET 7 is performance. All right. I don't think that you're going to upgrade to .NET 7 just because of the lesser features, but you will upgrade to .NET 7 because of performance. Just a huge jump. And there's some ARM64 perf improvements if you're in that space. There's perf improvements that affect WebAssembly and MAUI if you're doing Blazor WebAssembly, or if you're doing Android, iOS, or Mac applications with MAUI. And then if you want C#11, then you're going to go to .NET 7. The most interesting thing in C#11 is generic math. Now, they call it generic math, but what it really is, and I'm not going to go into the language, I just want to highlight this real quick, static virtual methods in interfaces. It used to be that to create operators in your classes, if you wanted to, say, enable implicit assignment from a string to a custom number type, you needed to implement the equals operator, the assignment operator that kind of did the parsing under the covers. And that's a static method in the C# language. Well, interfaces have never had static methods. Well, now with C#, you can add static method definitions on interfaces. And then when you apply an interface to a class, that class automatically gets new static methods, and the implementation is on the interfaces. And so for operators, and of course, math is tons of operators, that is hugely important. So give that a go. I am a fan and an advocate of adding operators and type converters and really using the full type system in your C# objects and truly going object oriented. It makes the code just read so much better. So C#11 is that generic math is pretty interesting. And then .NET.exe publish for containers was also announced, and it hasn't been integrated in lots of places. So I think some other tooling needs to catch up, but it was announced. All right, so that's .NET 7. That's probably I'll show it to you, but that's probably the least significant of what we're going to cover today. Now, Azure Container Apps, this is the most exciting part. What is it? It's Azure App Service wrapping Kubernetes. It's the simplicity of the feel of an Azure App Service, but the underlying power of hosting your app in a container inside Kubernetes. And some of the key features are dynamic scaling, scale to 0, scale to idle. And let me talk about CADA, Kubernetes event-driven autoscaler. You know, the built-in HTTP scaling and Q-link scaling and CPU scaling, that's interesting. But the custom CADA scalers give you 56 more avenues on when you can automatically scale to multiple instances of your containers running. And that's just like having multiple instances of an app service, multiple server instances of an app service. So you have a web farm, same thing, multiple of a particular container scaling. And you can scale it based on custom metrics in Azure Monitor. That's one of the CADA scalers. So think about this. Your code can define a metric, push it out to Azure Application Insights, and based on the value of that metric, your Azure Container App scales up to more instances. So effectively, that lets you have a C# code-driven way to choose when to scale up or when to scale down. So you can really control the logic in a fine-grained way. So that's pretty interesting. It also has environment variables. It also has secrets, so that you can put all those in the app service or container app configuration. Okay, so let's highlight the existing and stable technology that you're going to see, but we're just kind of gloss over and see how the latest in .NET and Azure Container Apps works. We want to take the current best of breed and integrate the big new tech announcements, and we're going to dig into that. And by the way, the code that you're going to see here is not, unfortunately, not currently available, and it's not in a current shareable state publicly. Haven't gotten to that point, but if any of you have an immediate project where you really need it, just send me an email and I'll bend over backwards to get it to you in whatever form or fashion and get you going down the road. So we just don't have it published in a way where I can just kind of send out a link and there it is. All right, so we're going to be using Azure. We're going to be using Azure DevOps, and we're going to be using Octopus Deploy, and we're going to stitch it together. And if you are a longtime follower of our webinars, then you'll know how our guidance on how to properly marry Octopus Deploy with Azure DevOps. We're doing the integration builds and testing in Azure pipelines, and then orchestrating a pipeline where we have Microsoft account permissions for approving to go to UAT, approving to go to production, doing full system testing in a deployed environment in Azure pipelines, but let Octopus Deploy do the deploying and all of the operations and the runbooks and the maintenance of the environments, which Octopus just excels so well on, especially on the ops side of DevOps. Whereas Azure Pipelines is really focused on making changes to the software and moving them along and pushing them, but really doesn't touch on the ops side. So marrying them together, they work really well. Again, we're not going to go deep into the feature set of either Azure Pipelines or Octopus Deploy. We're just going to take Azure Container Apps, put it in there. If you need to go deeper in those, give us a call. There's tons of tutorials out there, that content. Okay. All right. So let's give you a quick application demo and show you that we just took a Blazor WebAssembly app and we added onto it, added some additional functionality, added a SQL Server database so that we had a database to deploy as well. And we're going to show you that. So let's kind of jump on. Let's kind of jump on under the hood. Okay, so first of all, I'm going to open up Visual Studio and show you the structure that we're working with. And let me go to the top level. Okay, so I'm a fan of ReSharper's tools, but I like going at the solution level and just showing the architecture of an application like this. And when it kind of generates it, you look at it and like, okay, but I like to kind of rearrange it so that all the dependencies go upward. And so you can see that the structure of this Visual Studio application is kind of uses the Onion architecture flow. That's what I guess Onion architecture is 14 years old now. It's been in several books, and I have a series of blog posts in 2008, and lots of people talked about it in user groups around the country. But if you've never heard about Onion architecture, just do some internet searching, you can learn about that. But the gist of it is we have our core library that doesn't depend on much of anything except just very stable .NET framework types. It's not going to depend on a data access technology, a messaging technology. It's not going to have any dependencies that would cause code to call out of process from the code in core. But we want to put as much code in our core project as possible, very light on dependencies. And then all of the rest of the projects are going to reference core because core owns all the abstractions. And so you can see we have a data access project, which is going to use Entity Framework and call the SQL Server. We have some unit tests for it. And then we have our UI.client, which is Blazor WebAssembly, and UI.api and UI.server, which I'll talk about in just a second. And then we have our integration tests that do have to reference a lot of things in order to do those tests, and then our full system acceptance test. Then we have a database project that really isn't connected, but what it does is has SQL scripts for creating tables. This sample application is for displaying events at a church, like church bulletin type thing, or printing out a church bulletin. So that's kind of the language that you see here. All right, let me go into the build script. So we have multiple test suites running. And what's important here to just enable the situation is that we have a good and stable build script, and build.ps1 is where it is. And if you've seen my previous webinars, this is the clear measure way standard build script structure. Now, no two builds are exactly the same, but, and I'm done, 173 lines. At the top, it's just variables. And the values of these variables tend to be different from application to application or microservice to microservice. But you have things like the name of the project, the path to the integration tests, unit tests, acceptance tests, the UI or the startup project path, the database. And then on the build side, we have variables that are either passed in from environment variables or are going to have a default value. So our version, the build number is coming in from our build server from Azure Pipelines. Okay, that's the version. But if there's no version, in other words, if I'm just running it locally, well, then just kind of hard code 1.0.0. But we need the build number to come in. Okay, so that's that. So we need the build, and let's look down at, and by the way, I'm not going to go through all of these various command lines, but that's why we have a template for this, because there's the command lines of .NET.exe, you got to tweak them out, you got to get them just right. You never use .NET.exe build and that's it. You always need to tweak it. All right, so we have our unit tests, we have our integration tests, we're running tests, but let me go down to packaging, because if we're going to have something that's deployable, then we need to package it up. And so I'm going to come back to this. But we have a function for doing a .NET publish of our top level project, which is our UI, and then also for our database. And so we're also using Octopus Deploy's .NET add-in, .NET-Octo, and it creates really well formatted NuGet packages that can be put into Azure Artifacts. And so that's our packaging logic right here. Now, let me talk about application startup, the application startup refactoring real quick as I go through here. But Azure Upgrading from .NET 6 to .NET 7, by the way, there's just a few things. For this, it's going to be .NET 6. Just change it to .NET 7 and you're fine. Same thing. Every one of these projects is going to have target framework, .NET 6.0. You're going to change it to .NET 7.0. But some of the things like entity framework, server abstractions, you're going to find the versions are maybe 6.0.1 or something like that, and you're going to upgrade those to 7. You can right click and you can go to manage NuGet packages and you can look for updates, and of course you can do it that way. And consolidate is also a good tool. But if you just do a find and replace, look for anything where a version equals 6 point something, and likely those are from Microsoft and they need to be upgraded to .NET 7. Now, for the startup of this application, that's going to be relevant in the container. UI.server is the start of our Blazor application. Okay, and so that's important. It has the responsibility of starting up the application. And just so you know, we have refactored the web services into a separate project called UI.api so that we can manage our dependencies. Because if we go back to the architecture, UI.api has or UI.server is going to have references to all kinds of dependencies because it needs to wire everything up in the services collection. Well, we don't want our web API controllers to be in a project that has references directly to data access, because then IntelliSense is constantly popping up suggesting us to use APIs that we should not be using in a web API controller. So we've refactored it off to a different project. Okay, I don't want to go too deep into this because I want to get up to the deployment things. All right, so let's move on. I'll just give you a few tips on upgrading from .NET 6 to .NET 7. And let's talk about building. So I kind of built one. All right, this is the top level. And anytime you set up an application for automated deployments, it starts with the integration build that can be used in the, or starts with the private build that can be used in the integration build and some helpers or some capability for full system testing. But let's just run this particular build. And while it's running, it takes about 50 seconds to run. But while we're doing that, let's just do we kind of do a poll in the webinar real quick. And so I'm going to launch this poll and go ahead. Let me know, what version of .NET are you guys currently using? That's the first question. And then what work do you primarily do? Do you normally work in and on a software team? Are you the lead engineer? Do you help lead a software team? Are you the manager or the architect? Or are you in company management and just do the budgets and kind of oversee and write the check for the software team? And let you do that there. As the results come in. All right, I think that's enough for our poll. Okay, go ahead and end that. All right, just so everybody can see the result. Looks like we've got a lot of people using .NET 5.6, and looks like about 8% are using .NET 7. And about a third of our audience is in a leadership position. So, all right, always good to know. Okay, so let's get back to our build. So we're running our tests, and I'm not going to get into all of this, but I love to make sure that we have code coverage integrated into our builds. We have our database being created here, and then our full system test code coverage. And we're using Chrome driver for some Selenium tests for some low-level tests. All right, I'm not going to dig into that. but we're going to go ahead and kind of set that aside. One thing that I really love in a build script is just to be able to run the full system test easily. Okay, so let's move on and let's highlight something else that's going to be important when you deploy, and that is our health checks. So if I have this application right here, and I do Control F5 and I run this application locally. All right, let's just do that. So it's running here and it pulled up. And by the way, notice I have added the running of the health checks to the beginning of the application. We're going to do that. But also, I've added underscore health check. So I have an API, no, not underscore health check, but just well, that was the URL. Let me show you. No, not there. I run it at the beginning. My apologies. We're running it explicitly when the application starts up, not via URL. So we're running these directly, and let me show you where they're running from. In UI.server, we have program here. And so we're calling get required service, health check service, and we're saying check health. And what that's doing is that's crawling all of the different health checks in every one of the projects and running it. So we have one is 64-bit process health check, and all of them implement the interface iHealth check. And literally, it's going to make sure that we're running in a 64-bit process. And this is why, by the way, the Azure free tier on App Service and some of the other ones only support 32-bit. So it only supports a little over 2 gigs of RAM from a memory perspective, memory usage perspective in the process side. And so we use it's very common to use the Azure free tier just to try things out, but then you carry that infrastructure that you created and you end up being a production environment or a UAT test environment, and you don't change from 32-bit to 64-bit. And then you end up accidentally running your production application in 64-bit, constraining it to that lower memory level. And that's not cool. And so this is one health check where it doesn't matter where we deploy it. Hey, you know what? It's going to assert that it's running in a 64-bit process. Same thing with the database. Let's go to our data access, and we have a health check can connect to database health check. It implements the interface iHealth check. It has constructor dependencies. It has an iLogger and a data context from Entity Framework. And literally all we're calling is, hey, if I can't connect to the database, which through the data context gets the connection string and all that, well, guess what? I'm unhealthy. Okay. And so when the application first starts up, you have these little classes that do whatever you need to check all the various dependencies. And that right there, it's in the code, but every single time you deploy with Octopus Deploy, you want the application to start up and check to make sure if it's healthy. And if it's not healthy, well, you want the application to crash in a spectacular way so that the Octopus Deploy process fails and says, this was not a successful deployment. You don't want Octopus Deploy to say, this is the deployment finished. Why? Because I copied files and spun up an Azure container. And no, you want it to say the deployment succeeded and the application is actually running and it's doing what it's supposed to do. And so we don't want the startup process of our application to actually succeed if it's not right. Okay, so that's the health check. Now let's jump into the pipeline. So we're going to start with Azure pipelines. This is the pipeline configuration. I'm just going to kind of blaze through this real quick, and then we'll go deeper. All right. So this is the latest. By the way, I moved this application for this webinar into a different into the Clear Measure Labs organization in Azure DevOps. And in doing so, this is going to happen every time. You get it started, the build works, oh, but the next environment doesn't. So you got to tweak something. Then you tweak something, oh, that didn't, okay, now we got that environment working. Now we got to tweak something else for the UAT environment. Okay, couple times, okay, now it's working in the UAT environment. Okay, let me tweak, and now I got the production environment, and now we're good, and then you're good and stable from then. That's just the way it goes. So don't feel bad if that happens, and that whenever you change to different projects, and even in Octopus Deploy, that's just the way it goes. You kind of tweak it forward and you look at the next error message and then you fix it. And now once it's stable and it's working, it's golden and it's just automatic and the team can move fast. All right, but let's jump into this particular one. And oh, it looks like that one had a delay. Okay, so we have the application, we're capturing our test there. That's our integration build, build the application, then deploy to TDD, deploy to UAT, deploy to prod. Okay. For deploying to TDD, we want to deploy using Octopus Deploy, but then we want to come back and do some testing. Okay. I'm not going to cover that, but for UAT and prod, it's actually really, really simple. We are effectively just Dockerizing the release candidate, putting it in Azure Container Registry, and then say, Octopus Deploy, go ahead and do the deployment. So Azure Pipelines builds and prepares candidates for deployment with all the testing that goes into it. And then Octopus Deploy actually does the environment creation, does the deployment, and then of course, for further on, does operations and maintenance and run books and multi-tenanted environments and all the other good stuff that Octopus does well. But that's the integration point. And using that strategy, it allows us in Azure Pipelines to see all of the environments and know what the status is. And if we have product management or stakeholders that want to be able to press a button to approve a deployment to production, it allows us to do that with our Microsoft accounts right here in Azure Pipelines, but then leave Octopus for the more op-centered people. Now, I will say, if you are not using Octopus's tenanted environments and you have one production environment, then this works great and this is seamless. If you have a situation where you have multiple production environments based on a tenant name, then this strategy is not going to work for you. You need to just do the integration build and your TDD environment, which stands for test-driven development, by the way, in this fashion, and then just punt over completely to Octopus Deploy for the rest of the pipeline, because Azure Pipelines doesn't support tenants and it just gets confusing. Also, if you happen to be using GitHub Actions for your integration build, then you're going to want to do the integration build in GitHub Actions and then call over to Octopus Deploy from there using the create, release, and deploy, and then promote from within the Octopus Deploy dashboard. Okay, so this is the Azure Pipeline side, and just give you a sneak peek real quick to let you know how we pass the build number into Octopus Deploy when we push it over. So that's important because we have, let's see, what is build number 1.1.42, and then 43 went forward. Now over in the Octopus Deploy, sorry, let me go back to overview. In the Octopus Deploy, 1.1.43 is the latest one. We see the TDD environment, the UAT environment, and the production environment, and we see that the release numbers is exactly the same. Traceability is important here. I'm gonna highlight that. Okay, so we have that. We're gonna dive into this more a little bit. Let me also show you the resource groups we have in Azure. We advise our clients most of the time to put production environments in a Azure subscription that is specifically for production environments, and put non-production environments in a different Azure subscription that is not for production environments. The Azure subscription is the best security boundary that we found, as well as a cost management and billing boundary. Pre-production environments come and go and whatnot. And if on weekends or if nobody's working, all those environments could just be spun down and you don't have to spend anything on them. But on production, even if you lower the capacity, you're still going to keep them running. Also, with pre-production environments, it's really convenient to let somebody be a co-administrator of the subscription or maybe an elevated contributor. But in production, you want that to have much tighter authorization lists. And so I just want to call that out. We tend to advise that not to mix non-production environments in the same subscription, Azure subscription, as production. Now, technically, Azure makes you think that it's possible because you can have permissions on different resource groups and all that. And from a technical perspective, there are people who are doing it. It doesn't fall into place nicely, and we've seen it done wrong too many times. That what falls into place more easily is to have non-production in a separate subscription than production. All right, but anyway, we have our 3 different resource groups for each environment, and we, regardless of subscription they're in, we tend to do that. Let's jump into the Azure Container App for our TDD environment. Let me just show you the overview. If you've never looked at this, this is an Azure Container App that was created automatically by Octopus Deploy, running a ARM template. And yes, there's Farmer, there's Bicep, but just for now, nobody likes to hand author ARM templates, so we just use a generic one. This is the application URL, which we'll come back to. If we click over to containers, we can see which container tag it's looking at. We can see that this container app is looking at a Azure Container Registry. The particular registry that it's looking at is cmonionacr.azurecr.io, and the repository is onion. Now this is called image, but repository is kind of like a super tag. And then the image tag is, guess, 1.1.43, rather TDD-1143. I'm going to talk a little bit later about your options for tagging and your options for where configuration lives. But I just wanted to show that to you. And if you wanted to edit and redeploy, then you can kind of scale up right here. You can say, oh, give me a whole lot more container instances, or you can go to the container and you can check this. And here's the container running. It's running as different credentials there, and you can change. The ARM template is going to give you how many CPU cores you want. You can go down to 0.25 and half a gig of memory is the lowest that you can go. You can add all kinds of variables. So if you want to put this in development mode, you can do that by a manual entry, just by putting ASP.NET Core environment development, or whatever environment variables you want. That's where you do that. Okay. The container registry is right here. So let me trace back. This is the container registry. You're going to create that. You're going to create one of these. You're definitely going to create one of these for your organization. You may create one of them per team, and you may create one of these per software system. Depends on your strategy. There is not a one size fits all, but you want to make sure, if you're sharing a container registry with another team, to make sure that it's a team you highly coordinate with. You don't want to have one container registry for an entire organization where you have tons of images and you don't know what's junk and what's not, okay? And so if you don't know how to share yet, defer sharing and just have the container registry for one particular application. Then you go, repositories is the next level down. And by the way, the access keys is kind of how you put those into Azure DevOps. Okay, you're going to need that. We have a repository. You cannot create a repository in here. The first time that you create an image and push it into the repository, you give it the name of a repository, and repository is kind of like a super tag. It's just a tag, and then this will pop up. And so we have onion in here. We open this up and we see all the different container images from all of our different release candidate numbers and environments. And we are showing you this particular strategy where, yes, there are 3 different container images for version 1143. And that is because there's 2 choices here for managing your configuration settings. If you are porting an application that is heavy on settings in app settings.json or web.config, and you want to keep it that way, then before you actually create your container image, you need to push in all of the settings and the keys into your web.config and app settings.json. And I'll show you where that is before you create the container, because the container is immutable once it's been created. And if you're going to push in keys, well, guess what? Those keys are environment specific. So now you have an environment specific container. Therefore, it's appropriate to put the environment name in the image tag. Why? Because in the Azure Container App, you create the container app and you tell it, it's basically, think of it like a file watcher on a file system. The container app, how it's built to work is it's built to watch a particular registry for a particular repository for a particular image tag and run that. Okay. So I have TDD 1143. Now, if I were to find out that I made a mistake on the setting and it wasn't something where I was going to run a new build, let's say it was in production, and I realized, oh, I need one of the settings to be different. Now in app service, you can actually reach in and you can use a command line or whatnot, and you could change, the web.config or app settings.json because it's running on a server, and you can do that, and those are mutable up until you totally redeploy. But for containers, for the auto scaling, it's taking the image from the container registry and deploying. So whatever that image is. And so you have to change the image so that when it reaches and grabs the image, you change it. So if you deploy a new image with a changed setting, app settings.json key in it, and you use the same image tag, PRD-1143, and you put it in the container registry, then the Azure Container App that's watching that tag is going to say, wait a minute, I have a later container with that same tag, and it will basically auto swap all the containers and restart kind of out from under you seamlessly. So that's how it's built to work. Okay. So if you have an existing application and you're choosing to keep the configuration as you've had it, then you will need to push environment configuration before the step where you create the container. And I'm going to show you where that's done. If you want to change your configuration to read from environment variables or whatnot, that's no big deal, or it's a brand new application, well, then you get to choose. You can have all of the configuration be read from environment variables instead of app settings JSON. And in that case, you won't have any environment specific settings in a config file. So you don't have to have the environment name in the tag. You could just have a container for 1143, regardless of environment. But in the Azure Container App itself, you can set those secrets and you can set those environment variables. So if we go to, that's the container registry. If we go to the container app itself, we're going to see we have secrets for, connection strings, whatever the private stuff is. And then we can also define environment variables. And of course, you can poke around in the console, but it's not particularly helpful. This is why. Your container doesn't have much on it. So, if we do, like, let's see, cat, well, let's just ls. All right. This is our application. And this probably looks familiar. It's your DLLs, it's your app settings. And if we do cat app settings.json, we can see what's in the app settings file. Okay. So we can read what's there, but look at this. We don't even have enough to even do a ping. We don't have a VI. We don't have pretty much anything. And we definitely don't have PowerShell. Okay. So unless you just add a bunch more stuff to your Docker container, it's going to be pretty bare bones, but that's intentional. Okay. That's intentional. All right. I showed you the container. I didn't show the application running. I showed it running locally, but look at this URL. Actually, just to prove, we're going to go back over, and this right here, this is the URL we're going to copy, and we're going to paste. There it is. And the counter works just fine. This is hard-coded data. This one right here actually reads from a database. Okay. And to show you that it actually reads from the database, let's go over to the database. And I'm going to show you, this is the TDD OnionDB database. And we want to show you the code, show you the data. So let's just select top rows, and you can see it's the same data. All right, so now you believe that it's the same data, but let's go to the database. How do we make an Azure Container App, or how do we tell Azure SQL to let the Azure Container App through its firewall? Because Azure SQL's networking is pretty darn tight. You just can't get into the Azure database. You actually have to configure the link between your Azure Container App and Azure SQL. Let me show you where that is. And of course, this is all done. This is in the ARM template, but just where you can see and inspect and make sure. So we go to the server, then we go to networking, and public network access, only selected networks. So we can add a firewall rule. This right here is one of my IP addresses so that I could actually do that querying. And then this checkbox right here, okay, allow Azure services and resources to access this server, okay? And so that means that it's, for while you're developing and while you're getting everything running, you can check that box. You can say, okay, if it's inside Azure, go ahead and let it get there. And that way you get it working. And then later on, when the IP addresses of your actual components have settled down, then you can uncheck this box and then you can add specific firewall rules. But while you're getting things working, you check the box, and then within the Azure IP ranges, you know, you're allowing Azure services to reach in to this particular database if they know where it is and if they have credentials. Okay, so that's that. Okay, let's keep moving because we still have a lot to cover. All right. If you've seen our webinars before, then you have probably seen this poster. Now, this is only the top third of our DevOps architecture poster. That's right here. This is meant to be printed on a 3-foot by 2-foot poster board. And by the way, if you don't have it and you would like the high resolution PDF of this complete poster, just send me an email or look in the chat. If you send me an email if you need any help getting the poster, the book, anything, and I'll be happy to help you out. But this is the sequence of events for your DevOps environment, and I've kind of highlighted a few things, and I'm going to highlight a few more things that are different because you're using Azure Container Apps. But this is the flow. You have your integration build. You take the resulting packages from your integration build and you put them in Azure Artifacts, which is package management. Then you move along a minimum of 3 environment flow, because nobody has fewer than 3 environments. There's one of each type. You have production, that's a type. A manual test environment, that's a type. We tend to call that UAT, user acceptance testing. There's all kinds of names that you can give manual testing environments, but you need at least one. Then you need an environment for automated testing. This is no humans allowed. This is the TDD environment to invoke the spirit of test-driven development. And because we need to know that with a new release candidate, this thing still deploys properly on a production-like environment, and then we run full system acceptance tests against a fully deployed instance of the complete application to make sure it runs. And we integrate this with Octopus Deploy by letting Octopus Deploy do the deployment, and then control comes back to Azure Pipelines for subsequent testing or logging and the permissions integrated with Azure boards and all that. And if you're using GitHub Actions that is less sophisticated on the pipeline front, then you would just stop at the TDD environment, and then the rest of the deployments, you have to do all inside Octopus Deploy. Now, this is just for promotion. This does not cover managing multi-tenant environments. This does not cover runbooks, backups, scaling, all the other operations stuff that Octopus does so well. This is just from making a change to doing the builds to getting a new release candidate and getting it out there. Okay, but this doesn't change. Okay, so let's keep moving. Your source control. The way you manage source control, because you're using Azure Container Apps, that doesn't change either. Whatever is in a single Git repository, you're going to build all of it at the same time. It's going to be the same version, and you're gonna build it all, test it all together, and then package it up into deployable packages and move it forward. Okay, this is the structure of a build, whether it's a private build or integration build. You're gonna stamp a version number. You're gonna create your storage services like the database. You're going to do a compilation, your unit tests, integration tests. And then for your integration build over the top of a private build, you're probably going to do static code analysis. You're going to package the results in a format that Octopus Deploy can handle. And then you're going to publish those out to Azure Artifacts. Let me touch on when you should be interested in Azure Container Apps in the first place. Because you have this whole spectrum of where you can host your code. You can have an on-premise data center with physical servers. You can do hosted VMs. You can do a VM in Azure. You could do Azure Container Apps, or you could do Azure SQL or Azure Functions. Now, the reason that Azure Container Apps isn't the furthest to the right is because the furthest to the right would be 100% hands off, okay? And completely serverless is 100% hands off. Azure SQL, that has a serverless mode. Azure Functions, that has a serverless mode where you're just saying, hey, run my code, but I'm not going to back up. I'm not going to monitoring it. Azure Container Apps, you're pulling back just a little bit because you're saying, you know what? I need to have some say about the dependencies that are going to run here. And with Azure SQL, you're just giving it your schema, you're giving it that, and it's just running it, and it's auto-scaling the database. Functions the same way. With Azure Container Apps, you still have to create your container. You still have to own the definition of your container, which is the slice of a Linux operating system. And so there's just a little bit more control that you have. At the same time, there's more constraints. So the further you go to the left, the fewer constraints you are, but the more work you have to do. The further you go to the right, the more constraints there are, but the more you have to release control. Let me give you an example. If your application has a screen that that prints barcodes and needs a custom font to print barcodes, well, guess what? You're not going to be using Azure Container Apps. You're just not going to be. You're not even going to be using Azure App Service, because with an Azure Container App, you have to have the ability to install a custom Windows font, and you have to use one of the services that does support installing a custom Windows font for those custom barcodes. A lot of those barcode fonts are custom fonts that are not built in to the operating system. Okay, so I talked about packaging. Here's the mapping. Forget the offline job. That's just this code base doesn't have the offline job, but you could have one Visual Studio solution. And if you have an offline job that's just listening for a queue and a Blazor WebAssembly application and a database, and then a full system acceptance test, you have 4 deployable pieces of a single release candidate. All of this would be version 1143, but you have 4 things to deploy. Okay, and so you push them into Azure Artifacts, or you can push them into Octopus Deploy's artifact store, but Octopus Deploy is only for Octopus. So for your full system test suite, that needs to go in Azure Artifacts so it can be pulled back out inside Azure Pipelines and run those full system tests. So that's how that relationship is. This is a screenshot of Azure artifacts. This is the feed for the container app. And notice that we have the UI, we have the database, and we have the acceptance test. We have 3 different NuGet packages. Inside the .ui NuGet package is our Blazor app, is our app settings.json, is all the stuff that's going to go inside that container. Inside the database is our DDL, our data definition language. And that we're not containerizing that. So there's nothing about a container for this. And the acceptance test is just, we're going to run that with in-unit. There's nothing containers about this. So when we containerize an application, we only containerize the component of our application that is containerizable. And in this case, it's the web application, right? I highlighted this. I want to go deeper and show you how we get the full traceability of a build number all the way through Azure pipelines to Octopus Deploy to the container, to the Azure Container App, to the image repository, and then finally to the application itself. So we're tying it all together, and then we'll be done. All right. So let's get into that. I think we talked about this already. Okay. So let's show you. We showed you how we have the, at the top, we have the build environment, build number. Okay, let's go through one by one and just piece out where that goes. So if I were to go to the build definition of this, which is our Azure Pipelines YAML, I'm not going to go through everything, but the name of this makes the build number. So we default 1.1. Whatever the revision is. The latest one was 43. Okay, 1.1.43. Then if we go to, let me just shrink all these. I'm not going to go deploy UAT, deploy TDD. Okay, so here's where we have, let me just pull up UAT. And what we're doing here is we are pushing in an environment variable with the build number so that it's there. Okay, we're installing the Octopus Deploy tools, and then we are telling the Octopus Deploy server to go into the AZ Container App project, the environment UAT, and deploy release number 1143. Okay, we're passing in that variable. Got it. Okay. And oh, by the way, the containerization of this, I didn't show you one of the pieces. It's not relevant, but the Docker file. Let me just open that in. This is it. All right. I didn't want to pass this up. Literally, oh, I think the one we have, that's literally the only difference. Okay. So all we're doing, the port number, we are pushing files into a /built. And so we're copying all the files, which is a Blazor application. We have to put that in /app. This just gives us some logs right here. We're running an ls command. And then we're calling .NET on UI.server, which is our startup assembly. Okay, that's it for the Docker file. But I just wanted to make sure I showed it to you. Okay, so inside Azure Pipelines, we have that. And we are containerizing. We're capturing the variables of the, this is where we get the connection string. So now we have the connection string, and we're going to inject the connection string into app settings. So json.connectionstring.sql, and we're setting the connection string. Then we're telling Docker to build and push to the onion repository using the Docker file with the environment name, which in this case UAT dash, and the build number. Okay, that's our traceability to create the image. Now we have the image, and so now we're telling Octopus Deploy to take that image and deploy it. Okay, so now we're over in Octopus Deploy, and we have to look at our variables. Boom. We have a lot of variables here, but we have our container image, which is TDD dash, and then octopus.release.number. Because we passed in the build number for the release, if we go to the overview, guess what? The release number is 1.1.43. So in our process, in our variables, now we have the tag for the container. And in our process, for our Octopus Deploy process, we do the database stuff, which we're not highlighting today. and then we deploy the container app arm, and it's going to run directly on a worker. So it's not a machine that we have to mess with. And we're using a connection to Azure, and the source code right now, for long term, I like having the ARM templates in source because they just are templates. They don't vary for environment. But for this particular sample, it happens to be right here. We're tweaking stuff. So default value onion, I'm going to kind of cruise through a bunch of boilerplate stuff that just gets in the way, because none of us are ARM experts. But you saw when I showed you, these were the two secrets that showed up. We have our ingress rules allowing target port of 80. We are going to allow 100% of the traffic to be going to a single container. And then we're not using Dapper. That's templated stuff. And then we are essentially, this is where we tell the Azure App Service to create itself using half CPU with 1 gig of memory, and the initial scale from 1 to 3. Okay, so that's where this gets all the definition. But you think, okay, cancel it. All right, you think, where did the version actually get into it? So the version number, repositories, onion, the container image, the stuff inside the container image needs the version number. Well, that happens way back in the build script, way back when we compile .NET build, and check this out. Version equals version. You want that, because let's just go to source UI server bin. Locals done it. Okay, let's just take one of these. Let's just take one of these and go to properties, details, and see how it's 1.1.1. That's our default local version. But on the server, that needs to be 1.1.43. Why? Because when we run our application, we want to be able to sniff the version number, 1.1.43. Well, what's this doing? Okay, let's go. We have a controller that's a helper called a version controller. All it does is get the current type, look at the current assembly, get the name, grab the version, spit it back out. That's our traceability. So when we look at a particular version, we have a /version URL that allows us to have complete traceability from the integration build all the way through the container image, the application, everything, Octopus Deploy 1.1.43, and we want every single thing to line up, okay? Every single thing. All right, let's close out. I know I'm a few minutes over. Everybody's sticking with me. With these different environments, you want to do more in your upstream environments than you want to be in downstream. You don't want to do anything in production for the first time. And so things like migrating the database, yeah, you're going to do that all the way through. But loading test data, recreating environments, running acceptance tests, all that stuff, you're going to do way more. That way, when you get to production, it's no big deal because everything's been practiced before. All right, let's close out with the quirks or the gotchas. These container images are immutable. And so if you're pushing your configuration into them, then you're going to need to label them with tags that have the environment name on them, because if any of the configuration changes, well, guess what? Now the image is going to have to change in some way. So if you want to externalize all your configuration, no big deal. Just change your C# code from getting things from the app settings to getting things from environment variables, for existing or some other variable store, and you're good to go. So the image tag is important. Also, you're going to want to build your code on Windows, like integration build on Windows, because most of us have Windows dependencies. And so if you have any Windows dependencies in your build chain, then you want to have your code run on Windows, whereas you're going to actually have the jobs or the part of the pipeline that builds the containers on Ubuntu latest, okay, on the Linux agents. And that does a really good job with the simple Docker file and containerizing a directory of files into a runnable container. And Azure Container Apps does have a lot of options but you just got to pick one and stick with it, and then maintain traceability from your containers and environments back to your release candidate and your build. As we close out, back to ClearMeasure, here's just a few examples that have really been able to move faster and deliver better quality and to run their systems with more confidence in Azure. If you're trying to do some interesting projects in-house, you do not want to outsource, but you want to up-level your capability in-house, then give us a call. That's what we focus on. We love elevating in-house .NET teams to be able to do more, even if it's just advice, or whether it's just kind of maybe jump starting an Azure Container App and then do some cross training, or having some fractional architect or your internal lead engineer or architect, if you just want some individual one-on-one advising. We love doing that stuff. So let me close this out, and I know we're over time. I think the questions that came through, I was able to answer those. If anybody has any questions, just send me an email, or you can email info@clearmeasure.com. I'm easy to find. Thank you for being with us. And again, if you want that poster, it's 2 foot by 3 feet when you print it at a print shop. It's high resolution, and we'd be happy to send it to you. So just send an email. We'd be happy to send you the high resolution version of that DevOps architecture poster. And thanks so much for being with us. And till next time, keep shipping.